Alright, so today we're going to start looking at some properties of logs. We're going to use these to do two things. One is we're going to take some log expressions that are kind of big and condense them down. And then in the next video, we're going to do the exact opposite. We're going to take smaller log expressions and expand them out. So mainly we're going to focus on these three properties right here, which are related to exponent rules. And effectively, think back to exponent rules that if we were taking an expression like, I don't know, 2 to the x times 2 to the y, we could condense that down and make it 2 to the x plus y. It's the same idea here with our logs, that if we have an expression where we're multiplying two things together, we can expand it out that way. Same thing here with division. If we had something like 2 to the x over 2 to the y, we can make it 2 to the x minus y. It's the same idea with log, except now we're subtracting the whole log expression. Now, a new property that we're going to focus on is this one up here at the top, where it says log of a to the n. That n, because it's an exponent, we can basically just bring it out front and make it n times log of a. And that's going to help us when we do some condensing. The other property that we're going to use eventually, not so much today, but maybe in a future video, we've already talked about it a little bit, but this one here, log base b of 1 equals 0. We can just expand that out, and we know that the log base b of anything will actually be 0. In this part right here, we're going to do change of base. If we have time in this video, we'll talk about it. If not, we'll get to it in a future video. So let's start going through and doing some problems here where we're going to take our log expressions that are already expanded out and try and condense them to a single logarithm or rational number. So we have here our first example. I'll just call this example 1. We have log of 6 plus log of 5. So I'm going to first figure out what properties could I potentially apply. I'm looking first, do I have any numbers out in front? I don't. So I'm not going to apply this property here. Effectively working kind of backwards with the property, going from this side to this side, from this side to this side, from this side to this side, and so on. I do see addition, so it looks like I can take these logs, and they have the same base right now. It's a base of 10, and I can turn that into log. And because I'm adding them, my rule says take those two numbers and multiply them, and it would give me the log of 30. I'm not going to find out what that number is because it's not something convenient or nice. If it was something like a log of 100, then I can turn that into a base 10, which if it's not written, it's a base 10, and I can find out pretty quickly that x would be 2. So that whole expression would turn into 2. But we're not really concerned so much about that right now. It's more about condensing them to one single logarithm. Now let's try a more complicated one, where we have log base 2 of 12 minus log base 2 of 2 plus log base 2 of 7. And so here's what we're going to do on this one. I'm noticing here that all of them have a log base 2, which is good news. The next step then is to figure out what properties could we potentially use. So I'm seeing right here that we have some addition going on, but I'm also seeing subtraction here with this piece. So I'm basically applying both parts. Now, anything that's being added, my rule says I'm going to multiply. Anything that's being subtracted, I'm supposed to divide. What I'm going to do is rewrite this. So I can more easily see that I should be multiplying these together and dividing these. So when I multiply the 12 and 7, that's going to give me log base 2 of 84. And subtracting means I'm going to divide. I'm going to divide by 2. It's going to end up giving me log base 2 of 42. Alright, what about a problem with some coefficients? So let's pick one like this. Let's put it over here. Example 3, we're going to do 2 log of 8 plus 5 log of z. So I do have some numbers in front, which means I'm going to turn those into exponents using this rule right here. So that 2 that's on there is going to go up here. That 5 that's there is going to go here. So when I rewrite this, it's going to look like log of 8 squared, and I might want to find out what that is in a little bit, plus log of z to the 5th. Now, what I have left is I have an addition, so that tells me that I'm going to be putting these together with some multiplication. So I'm going to take log of 8 squared, z to the 5th, and I'm going to find out what 8 squared is because I think it's relatively easy to do. I'm going to make that log of 64 z to the 5th. Again, I took that coefficient in front, brought it in as an exponent, and then applied the property of adding logs turns into a multiplication. And let's try another one. Let's do log of base 1/2 of the square root of x minus log base 1/2 of x to the 3rd. Actually, let's make that 3 log base 1/2 of x. All right, so here's our first step. We have some coefficients out in front. We're going to take care of those. I've got nothing here, but I have that 3 there. And so I'm going to make this log of base 1/2 of the square root of x. Actually, I'm going to rewrite that. And you'll see why in a minute. X to the 1/2 power. That's what square root of x means. And I take that 3 and bring it in, making it minus log base 1/2 of x to the 3rd. Now I have a division problem. The reason I wanted to turn that into a rational exponent is so that I could eventually do something with 3 and the 1/2. And so I'm at that step right now, I think. I've got log base 1/2 of x to the 1/2 over x to the 3rd, which is not simplified. We can do a little bit more with this. So what I'm going to do is try and simplify these guys down so it makes it a little bit easier. I'm going to find a common denominator, which would turn that 3 into 6 over 2. And my rule with exponents is if I'm dividing those two things, I can subtract my exponents. So I'm going to have log base 1/2 of x to the, 1/2 minus 6/2 is negative 5 over 2. Now if I want to get crazy with this, I can take that negative 5/2 and bring it back out. But because we're condensing it, I actually don't want to do that. So let's look at one more that's a little bit more complicated to do. Let me grab my pen again. All right, so in our 5th example, let's go with this one. 4 log of z plus log of z plus 5 minus 2 log of z minus 5. So there's a couple approaches I can take. One approach is I can take that 4 and I can distribute it. The other thing I can do is I can take my expression that's in those brackets and condense that down first, then take that 4 and bring it in. I think I'm going to go with that approach just because it seems like it's a easier approach to take. So I'm going to take that 4, leave it where it's at right now, and put these together with some multiplication. So this is log of z times z plus 5 and minus 2 log of z minus 5. Now what I can do is take that 4 and bring it in. And I've got a couple ways I can do this. I can put another set of parentheses around that and make it to the whole thing to the 4th power. Or not. I'm going to just write it as z to the 4th, z plus 5 to the 4th. And here I'm going to have minus log of z minus 5 to the 2nd. So condensing that down gives me log of z to the 4th, z plus 5 to the 4th, over z minus 5 to the 2nd. And I'm looking to see if there's anything I can do to simplify. And I'm not seeing it, so I think we're good to go on that particular problem. All right, one last thing I want to talk about here is the change of base formula. So the change of base formula has the log of b, or log base b of a, and we can change the base to whatever we want it to be. It really doesn't make a difference. I'm just going to call it 10 or whatever we want it to be. Usually we're going to do 10 because it's just easier. But I can rewrite that as the log of a, so this is the log argument, over log of b, which was the original base. So let's do a couple quick ones here. We're going to take an expression and rewrite it as a constant. So I'm going to take problems like log base 2 of 8, and I can rewrite that as the log of 8 over the log of 2. Now what that allows me to do then is to go through the process of simplifying this down a little bit. I can make that log of 2 to the third over log of 2, and technically we're doing a little expanding here, because now I can take that 3 that's in front and put that in the correct spot, and I'll have 3 log of 2 over log of 2, which we know this will turn into a 1, giving me 3. We can do the same thing with a more complicated one. Let's say we had log base 125 of 25. We could use the change of base formula, so it'd be log of 25 over log of 125. And I think I can turn those to 5s. Log of 5 squared over log of 5 to the third. Take those numbers in front, making it 2 log 5 over 3 log 5. And again, the log 5s will cancel, giving me 1. It's 2/3. Now, we can still do that in a different way. We can set up an equation, set that equal to x, loop around, and still get the same answer. But change of base might be a quicker, easier way for you to get the job done.